Okay, let's do the matrices. Let's continue with the exercise 3.2. Apart from the matrices intro video, this is a continuation of that where I'm doing the 18th question, which is the world's most important question. It comes in every school exam. If A is equal to 0 minus tan alpha by 2, a tan alpha by 2 and a 0, you have to prove that I plus A is equal to I minus A into cos alpha minus sin alpha, a sin alpha and a cos alpha. You have to prove this. So you know what is I. Let's prove the left hand side and right hand side separately. You know I, this is a 2 by 2 matrices, and identity matrices of order 2 by 2 is 1 0 0 1 plus A, right? A 0 minus tan alpha by 2, tan alpha by 2 and a 0. You have to prove this to be equal to I minus A, which means 1 0 0 1 subtracted by A, which is 0 minus tan alpha by 2, a tan alpha by 2 and a 0 into this matrices. Okay, this matrices which is cos alpha minus sin alpha and a sin alpha and a cos alpha. Just write it. Now you have to prove LHS equal to RHS. You know, addition of matrices, respective elements have to be added. So you get 1, a minus tan alpha by 2, a tan alpha by 2 and a 1, and this is the left hand side. Right hand side, let's do the subtraction first. So 1 minus 0 is 1, minus tan alpha by 2 will become plus tan alpha by 2, and this will become minus tan alpha by 2, and this will become 1, subtracting the respective elements. I hope I've written correctly. 1 minus is there, minus of minus is plus, this is minus and this is 1, subtracted. Okay, into cos alpha sin alpha. I would rather write cos alpha as tan alpha by 2, which is cos alpha is 1 minus tan square alpha by 2 by 1 plus tan square alpha by 2. A sin alpha is minus, and a sin alpha is 2 tan alpha by 2 by 1 plus tan square alpha by 2. A sin alpha here can be written as 2 tan alpha by 2 by 1 plus tan square alpha by 2, and a cos alpha is 1 minus tan square alpha by 2 by 1 plus tan square alpha by 2. Writing a cos and a sin in terms of tan alpha, this is the way. Because it is alpha, it will become alpha by 2. Okay, so you know cos 2 theta's formula in terms of tan is 1 minus tan square theta by 1 plus tan square theta. Because if 2 theta becomes theta, then this theta becomes theta by 2. That's the same thing that I've done here. Similarly, sin 2 theta is 2 tan theta by 1 plus tan square theta. These are two formulas which I'm trying to apply here. So that there's a symmetry, everything is tan alpha by 2. So now let's name tan alpha by 2 as t. To make it easier, 1 minus t, t1 is equal to 1 t minus t1. And here it is 1 minus t square by 1 plus t square minus 2t by 1 plus t square, 2t by 1 plus t square, and 1 minus t square by 1 plus t square. Now we have to do matrices multiplication. These two matrices needs to be multiplied. And how to do matrices multiplication? You know the middle order, this is 2 by 2 and this is also 2 by 2, and to do multiplication, the columns in the first matrices and the row in the second matrices has to match, otherwise you can't multiply two matrices. So you know the end product will be this extremes. 2 by 2 is what you would get when you multiply. And how are we going to multiply and write it? You know, it's first row first column, multiplication of first row with the first column. So I'll get the first element, you understand? First row with the first column, I should multiply this with this and this with this and add. Correct? Undo, undo, undo. Okay, multiply 1 with 1 minus t square by 1 plus t square, you'll get 1 minus t square by 1 plus t square plus t into 2t by 1 plus t square will be 2t square by 1 plus t square. First row first column, that elements have to be multiplied and total has to be added, because the first position stands for A11, which is first row first column. That multiplication you write it, fill it in the first position. Obviously second position will be A12, first row second column. So what is first row and second column? Here is second column. You need to multiply first row with a second column. This is second column and a first row. Are you clear? I'm going to multiply that elements and then add. Okay, so then while doing so, the first row with the second column will be minus 2t square by 1 plus t square, and this and this will get married, right? So then they'll get multiplied. So you get plus 1 minus t square by 1 plus t square. That is, I did first row, second column. So minus 2t, no, why should be t square? Minus 2t. First element with this will be minus 2t by 1 plus t square. And this first row, second column will be t into, right? Will be plus t into 1 minus t square by 1 plus t square. Correct? First row, first column is this. First row, second column is minus 2t by 1 plus t square plus t into 1 minus t square by 1 plus t square. So when I take this in, I'll get t minus t cube. Take the t in, you'll get t minus t cube by 1 plus t square. So this is what it is. Next is second row, first column. A second row, a second row and a first column has got to be multiplied. Last time I made a mistake, let's not make a mistake. So it's, when I take it in, multiply this with the first term, it's minus t plus t cube by 1 plus t square, and this have to be paired, plus 2t by 1 plus t square. Second row, first column. Next is second row, second column. Let me do it in different colors. Second row, second column. So this will become minus t with the 2t will become plus 2t square by 1 plus t square, and a 1 with this one will be just the same, 1 minus t square by 1 plus t square. Like this you slowly multiply first row, first column, first row, second column, second row, first column, second row, second column. Then try to solve it. When you solve this, can you see this 2t square and minus t square will be 1 plus t square, 1 plus t square will be 1. I won't even check, I'll just write this, because this is the left hand side I need. So when I solve this, I'm supposed to get that. Even if I made any mistake, I would have managed it. But see, what is this? This is minus 2t plus t will be minus t. When you take a minus t out, it will be 1 plus t square by 1 plus t square, where 1 plus t square, 1 plus t square get cancelled, get a minus t. Again, look at this term. You know, there's a minus t and a plus 2t, which will be minus, and there will be plus t. So you get a t and a 1 plus t square, 1 plus t square get cancelled. So are you clear? Can you see this will be a t square plus 1 by 1 plus t square. So answer is 1. Even without doing, you can just copy it, and so you're done with this question. So let's go to, we have proved the left hand side is equal to right hand side. Let's go to 19th question. A trust has got 30,000 rupees. They are going to invest in 2 different funds. Okay, which means one will be x, another will be 30,000 minus x. You have to write this in matrices. It will be x and this will be 30,000 minus x. And the rate of interest should be written vertically. Remember x, y, z we wrote vertically like that. The rate of interest for the first one is 5%. The rate of interest for the second one is 7%. And the calculated interest is given to be in option number A. They've given it as 1,800. Look at this, what row and what column? This is 1 row, 2 column, 1 by 2. This will be 2 rows and 1 column, and the end matrices will be 1 by 1, which is all we have. So you just solve it as first row, first column, that's all. First row, first column is x into 5 by 100 plus 30,000 minus x into 7 by 100 is equal to 1,800. Take this 100 that side. So you get a linear equation 5x plus 21,0000 minus 7x is equal to 18,0000. Just solve this, you get minus 2x, and take it that side, you get the minus, what will that be, 3, 0,000. So then therefore the negative sign, negative gets cancelled, so you can get x to be 15,000. So you can split it up equally, 15,000 and 15,000. For the next part of the question, you have to fill this as 2,000. Instead of this, you should write 2,000. So equate the linear equation with a 2,000 and then get different value. Are you clear? Let's go to next question. The next question is about the 20th question. The 20th question, if you see, there's a bookshop where there are 10 dozen chemistry book, which means 120 chemistry books. Then there is 8 dozen physics books, 12 8s are 96, 12 8s are 96, then 10 dozen, whatever that is will be 120, right? And the cost should always be written vertically. What is the cost that's been given? 80 60, 40. These are the costs per book. That is the reason I had to convert dozens into pieces. And you know, this is 1 by 3 matrices. This will be 3 by 1 matrices. So the end product will be 1 by 1. You do first row, first column. What do? You get 120 into 80 plus 96 into 60 plus 120 into 40 and add those respective elements. You get the total value. And that's all. It's this matrices way. That's all. So can I go to next sum? The next is sum. Can you see that the question starts with 2 lines above. There's an X matrices, Y matrices, Z matrices, W and a P. And the orders are written. Can you tell me what is X matrices order? 2 by? 2 by N. Next Y?
K. 3 into K.
3 by K, don't say into. Z?
2 by P.
2 by P.
N by K.
N by?
3.
3.
P by K.
P by K. These are the respective orders. They are asking you to find Py, multiply the matrices P and Y, and multiply the matrices W and Y. Correct? You know, for multiplication of matrices, the middle order has to be the same. What is P's order? Right? P's order? P by K. What is Y's order? 3 by K. The middle order has to be same. Therefore, to multiply, K should be equal to 3. What will be the N matrices? It will be P by K, or it can even be P by 3 because K itself is 3. Like that you can write. Now what is W matrices? Can you see? It's N by 3. What is Y matrices? It's 3 by K. And you know middle order has to be the same. It is the same. And the N matrices has to be N by K. And to add 2 matrices, the entire order has to be same. So then therefore you understand P should be equal to N and K should be equal to 3. Whatever the question is, you will be able to answer. So let's go to next question, which is the 22nd question. 22nd question, where the question is about 7x. 1 second, hold on. Shit. So the next question is the 22nd question, where if n is equal to p, they're asking about a matrices 7x minus 5z. You know the matrices is x. And merely multiplying a matrices by 7 means the 7 will get multiplied throughout inside but doesn't change the order of the matrices. It would not change the order still remains the same. A matrices Z multiplied by a 5 means the 5 is getting multiplied throughout the inside the matrices. That is not going to change the order of the matrices. So what is the order of X? Is 2 by n. Even if you multiply by 7, it will still stay to be 2 by n. And Z matrices is 2 by P. Multiplying matrices by a scalar 5 is not going to change your answer, your order, I'm sorry. So then, therefore, for subtraction, the order has to be same. Therefore, P is equal to n is one observation. The n matrices could be 2 by n or a 2 by P, and you can see what is your MCQ say and you can answer one of those questions. So, a 2 by n has been given, so option number, this is the right option, B, option number B. That completes this exercise. Next, let me tell you how something about transposing of the matrices. Okay. So what is a transpose? So let's take exercise 3.3. Okay, what is a transpose? First question, you have a 5, 1 by 2 and a minus 1, and let's call this as matrices A. The transpose of this matrices will be converting the column into a row, a 5, 1 by 2 and a minus 1. This is what is an A transpose mean. The second question, as you know, is 1, minus 1, 2 and 3, and this is A. You're going to write an A transpose, you're going to write a column as row, which is 1, 2, minus 1, 3. It's as simple as that. I don't have to do the third sum. So these questions, where second question, they're asking do A plus B, which means you're going to add A and B matrices and you're going to transpose it. Okay, you have to prove that if you transpose A and you transpose B and then add, is the left hand side and the right hand side the same? So these questions can be answered by you directly. You don't need a tuition teacher's help. You can probably download questions, these solutions from Byju's and straight away do it. Look at the fourth question. You have a plus 2b the whole dash. So which means the matrices B has to be completely multiplied by 2. The matrices B in that question is minus 1, 0, 1, 2. Which means you're going to multiply 2 with this. It's going to be minus 2, 0, 2 and 4. And you have to add that with A. What is A matrices? It's been given to be minus 2, 3, 1, 2. Is A matrices added with the 2b, which is minus 2, 0, 2, 4. Respective things you can add, so it will become minus 4, 3, 3 and a 6. And that is the answer. and you have to transpose this because this is what is A plus 2B. You have to do A plus 2B the whole dash, which means transpose it. The columns can be written as rows, and that should be your answer. Okay, so I hope you understood. You can continue doing these sums from Byju's side. I am going to start recording from the 6th question onwards. Okay, so simple things I'm leaving aside. So if A is equal to cos alpha, A is equal to cos alpha, sin alpha, minus sin alpha, and a cos alpha. Show that A transpose into A is equal to I. A transpose, just transpose this, you get row, columns into row, cos alpha minus sin alpha, a cos alpha into A. You can't change, you can't write as A into A transpose. Whatever is given, you should keep it like that because matrices multiplication is not commutative. AB is never equal to BA. But if it is equal, then B is an inverse of A and A is an inverse of B. Okay, now leave it, it's never commutative as of now. So then therefore just copy it as it is. What is A? Cos alpha, sin alpha, minus sin alpha, cos alpha. I've written this is equal to I. It's 1, 0, 0, 1. So then you have to multiply these two. So first row, first column is your first element. So it's cos square alpha plus sin square alpha. Can I write it as just 1 therefore? First row, second column. A cos alpha, sin alpha, minus sin alpha, cos alpha, which will get cancelled, become 0. Oh, to show that I should not equate it to 1, 0, 0, because you have to show that it's equal to. And I'm getting it. This multiplication, second row, first column. Again, sin alpha, cos alpha, minus cos alpha, sin alpha, which can be cancelled and become 0. And next is second row, second column, sin square alpha plus cos square alpha, which is 1. Oh, actually, you should write the steps involved. I just cancelled it and rubbed it off and wrote the answer. So it's as simple as this. Let's go to 7th question. 7th question, there's a matrices 1, minus 1, 5, minus 1, 2, 1, a 5, 1, 3. To prove it's symmetric, this is A, transpose it and see if it's symmetric. That is, write these columns as rows 1, minus 1, 5, minus 1, 2, 1, 5, 1, 3. In fact, you've written columns as rows, but is there any change? You got the same matrices. Such is called symmetric matrices. Such is called symmetric matrix. So this given matrix is a symmetric matrix. Nothing is changing. The next question is about skew symmetric, where A is given to be 0, 1, minus 1, minus 1, 0, 1, a 1, minus 1, 0, and you're going to transpose this. Okay? Which means you're going to write columns as rows. Okay? So you'll write 0, minus 1, 1, 1, 0, minus 1, minus 1, 1, 0. Look at this. Wherever there was negative, there's positive now. Skew symmetric. Such is called skew symmetric. The symbols will completely change. Such is called skew symmetric matrix. Okay, so then complete symbols will change. That's called skew symmetric matrix. Okay, so let's go to, you understood? So let's go to, next question is 8th question, where you have to do A plus A transpose. Do A transpose, add it with A, and then see if it's symmetric. Transpose and see if the symbols are not changing. The same numbers are occurring, it's symmetric. If it's becoming negative, it's skew symmetric, so I'm not doing that. Similarly, I'm not doing the 9th sum also. But generally, I'll give you an introduction. If they ask you to randomly write a symmetric matrix in exam, randomly write a symmetric matrix, you know what you should do? Take a matrix such as 1, 2, 3, 4, 5, 6, 7, 8, 9. Transpose it, okay? 1, 4, 7, 2, 5, 8, 3, 6, 9. You're getting different numbers when you transpose, correct? But you have to form a symmetric matrix. Just do A plus A transpose. 1 and 1 adds 2. 2 and 4 6. 3 and 7 10. 4 and 2 6. 5 and 5 10. 6 and 8 is 14. 7 and 3 is 10. 8 and 6 is 14. 9 and 9 is 18. Can you see? This would be symmetric. Let's see. Let's do a verification. Write a verification. Write the columns as rows. 2, 6, 10. 6, 10, 14. and a 10, 14 and 18. Do you find any difference? So this we formed, this one is an example of a symmetric matrix. And how to get a symmetric matrix? Take any random matrix, transpose it and do A plus A transpose, you will get a symmetric matrix. Okay. Similarly, to get a skew symmetric matrix, take the same matrices and subtract. Do A minus A transpose. Do A minus A transpose. 1 minus 1 is 0. 2 minus 4 is minus 2. 3 minus 7 is minus 4. 4 minus 2 is 2. 5 minus 5 is 0. 6 minus 8 is minus 2. 7 minus 3 is 4. 8 minus 6 is 2. 9 minus 9 is 0. This according to me is skew symmetric. Just transpose and see verification. That is, I'm going to write the rows as columns as rows. 0, 2, 4, minus 2, 0, 2, minus 4, minus 2, 0. Just see wherever the negative sign is, it's become positive. Wherever positive, it's negative. So therefore, this will be a skew symmetric. This is just a verification. But that will be a skew symmetric matrix. This you should understand. So whenever they ask you in exam, randomly, write an example of symmetric or skew symmetric. Take some dummy matrices and do this. That's all. Next, I would do the 10th question. See, express a matrix. In that, I am going to choose a subdivision 2, where it is 6 minus 2, 2, minus 2, 3, minus 1, 2, minus 1, 3. You have to express this matrices as a sum of symmetric and a skew symmetric matrix. So you need a symmetric matrix and you need a skew symmetric matrix where you should be able to add them and get the question. Express this matrices as a sum of this plus this. How to get a symmetric? It is A plus A transpose. How to get a skew symmetric? It's A minus A transpose. What is A? You can declare this as A. So let's do A, which is 6 minus 2, 2, minus 2, 3, minus 1, 2 minus 1, 3 can be added with its transpose, which is 6 minus 2, 2, minus 2, 3, minus 1, a 2 minus 1, a 2 minus 1 and 3. That will be A plus A transpose. So what will you get? You will get a 12 minus 4, 4. You get a minus 4, 6 minus 2. You get a 4 minus 2 and a 6. Now you're going to do A minus A transpose, which means you're going to change the symbol here and do it. What will happen? You will get 6 minus 6 is 0. Minus 2, minus of minus plus 2. Minus 2 plus 2 will become 0. 2 minus 2 is 0. What? Okay. Minus 2 plus 2 is 0. 3 minus 3 is 0. Minus 1 plus 1 is 0. 2 minus 2 is 0. Minus 1 plus 1 is 0. 3 minus 3 is 0. Incidentally, in the sum, it's like this. Normally, it won't be. And you have to verify. These are the answers you got. You're going to verify. Verification. Whether this is symmetric, because this is a symmetric column and this is skew symmetric column. You just transpose it. 12 minus 4, 4. And minus 4, 6 minus 2. I'm not writing the same, okay? I'm writing columns as rows. 4 minus 2, 6. You end up getting the same. So verification is done. Therefore, this is your symmetric matrix. And this, as you know, is skew symmetric. I don't even have to verify it. And, the whole point is, it's not A plus A transpose and A minus A transpose. You have to additionally do one thing here. You have to do A plus A transpose by 2. And A minus A transpose by 2. Why? Because when you add it, 2 will be the LCM. A plus A transpose plus A minus A transpose, you get 2A by 2. 2 and 2 get cancelled, you get back A. To get back A, you have to divide it by 2. Both the symmetric and skew symmetric, you have to divide it by 2 and then add. So let's divide this by 2. A plus A transpose, you will get a 6 minus 2, 2. Minus 2, 3, minus 1. A 2, minus 1 and a 3. I divided by 2. This when 0 when divided by 2, I'll get only 0, 0, 0. Correct? So when you add this, you'll get 6 minus 2, 2. Minus 2, 3, minus 1. 2 minus 1 and 3, which is exactly the question. 6 minus 2, 2. Minus 2, 3 minus 1. 2 minus 1 and 3. That's all. So you got back A. This is a symmetric and this is a skew symmetric. So this is what you should do. You should do verification in both the cases, but here it was 0, 0, 0. I didn't have to do it. Otherwise, you have to do it. So let's take like this. You can try the third sum and the fourth sum in this exercise. It's all similar. So let's go to next question. The next question is the 11th question in this exercise, where they're given A is a symmetric matrix. Then A transpose is A. B is also symmetric matrix. B transpose is B. Prove that AB minus BA is Q symmetric or symmetric. To find anything is symmetric or Q symmetric, you should transpose and see. Since there's subtraction, you can write it as AB the whole dash minus BA the whole dash. In the product rule, in transpose, it will be in descending order. This will become B dash into A dash. This will become A dash into B dash. And you know B dash is B, A dash is A dash is A, B dash is B. So you can write minus of AB minus BA. So you started with this and you ended up getting a AB minus, negative of AB minus BA, showing that AB minus BA is a skew symmetric matrix. Even though A and B were symmetric, AB minus BA turned out to be skew symmetric matrix. So let's go to next question, which is the 12th question. The 12th question, where they are asking A is equal to, they're saying cos alpha minus sin alpha, a sin alpha and a cos alpha has been given. They are saying A plus A transpose is equal to I. What is A? A cos alpha, a minus sin alpha, a sin alpha, a cos alpha is A. Let's write A transpose, cos alpha, sin alpha, minus sin alpha, cos alpha is equal to I. It's been given 1, 0, 0, 1. So let's add this. You get 2 cos alpha 0, 0, 2 cos alpha is equal to 1, 0, 0, 1. In matrices, two matrices are equal, you can equate the respective value. So 2 cos alpha is equal to 1. A cos alpha is equal to 1 by 2. So where will cos be 1 by 2? Therefore alpha is equal to 60 degree or a pi by 3 radian. You also know, all school taught your children where cos, here also cos can be positive. But here the options, this will be 2 pi minus pi by 3. In that case answer will be 5 pi by 3. But there is no option like that. The question is only about the first quadrant. So pi by 3 radians is your answer. So that completes this exercise. So then this property is very, very important. As I told you, when you have product rule AB the whole dash, you can write it as B dash into A dash. Okay, and there's also similarly AB the whole inverse can be written as B inverse into A inverse. What is an inverse? You know the multiplicative inverse of 2 is 1 by 2. So inverse of matrices A will be, we don't say 1 by A. No, never say that. You just say it as A inverse. And how to find that I will teach you later. Okay, for now, just learn this property you're going to learn. How to start this proof. This proof is world's most important proof, where you write AB multiplied by AB the whole inverse. A matrices multiplied by its inverse. 2 into 1 by 2 will be 1. So matrices multiplied by inverse will be I, because I is equivalent to 1 in matrices. Okay, now you have to multiply both sides by A inverse. A inverse into A into B into AB the whole inverse is equal to A inverse into I. You know this itself is I. This itself is I. Because matrices A into inverse, its inverse is I. IB into AB the whole inverse is equal to A inverse into I. People will cancel this I and this I. I don't believe in doing that. Don't do that. A matrices I multiplied by B, identity matrices, when you multiply with any matrices, will give you the same matrices. So then therefore you can write it as B into AB the whole inverse. This is also matrices A inverse multiplied by I will just be A inverse. Now multiplying both sides by B inverse. This itself is I. So thus you got AB the whole inverse is B inverse into A inverse, a very, very important proof. So let's go to next. The next exercise is finding an inverse using elementary transformation, completely omitted. The 3.4 exercise is completely omitted. So you only have miscellaneous. So you take miscellaneous, and the first 3 sums according to the old volume is omitted. So let's do the 4th sum in old volume, where the question is A and B are symmetric, which means A transpose is A and B transpose is B. They are asking you to prove AB minus BA, is it symmetric or skew symmetric? We just did it, similar sum. You transpose and see, then only you will know. Since a subtraction, you write it as AB the whole transpose minus BA the whole transpose, descending order, B transpose into A transpose minus A transpose into B transpose. Substitute in the given, B transpose is B, A transpose is A, minus A transpose is A, B transpose is B, which is minus of AB minus BA. Since you started with this and got a negative symbol, that shows that the matrices is skew symmetric, even though the given matrices A and B are symmetric. That's the fourth question. Let's go to fifth question. The fifth question is this question, there will be a word accordingly asymmetric and skew symmetric. That is, they are asking you to prove if B dash AB, is it symmetric or is it skew symmetric. Accordingly, that A is symmetric and A is skew symmetric, which means when it's symmetric, A is symmetric. A transpose is A. When you are proving it's skew symmetric, A transpose will be minus A. Accordingly, when A is symmetric and A is skew symmetric. So then what you do, given matrices, you have to transpose and see. So descending order, B dash, A dash, B dash the whole dash. B dash, A dash, B dash, A dash into B. B dash whole dash is just B. You took this matrices and A dash is nothing but A dash is A transpose, which is just A. So you write it as B dash AB. You started with B dash AB. You started with B dash AB. You ended up getting B dash AB. Therefore, it's symmetric. Provided accordingly that A transpose is A is symmetric. Similarly, take the B dash AB and whole transpose. You get B transpose, A transpose, B dash the whole transpose, which is B dash, A dash into B. But A dash is minus A here. So it will become B dash minus AB. So the whole given matrices became skew symmetric. Accordingly, when A is skew symmetric. Hope you understood. That's what is this question. So let's go to sixth question. The sixth question is where they've already given A, which is 0, 2y, z, x, y, minus z, x, minus y, z. They are saying A transpose into A is equal to I. They already given this. Oh, find the value of x, y, z. So they've already given this. So write A transpose 0, x, x, 2y, y, minus y, z, minus z, z. Multiplied by matrices A, 0, 2y, z, x, y, minus z, x, minus y, z is equal to I. 1, 0, 0, 0, 1, 0, 0, 0, 1. We're going to do first row, first column, first row, second column, first row, third column. Like that you're going to multiply. So these first elements, so first A1, 1, first row, second, first row, first column, first row, second column, first row, third columns multiplication. 0 into 0 is 0 plus x square, so 2x square. First row, second column, 0 plus xy minus xy. So answer is 0. Just delete, I want to delete this. So it becomes 0. First row, third column. So it will be 0 minus xz plus xz. Again it will be 0. Next, obviously, I will guess and write 0, 2y square, 0, 0, 0, 2z square. You try multiplying the second row, first column. 0, yx minus yx, 0. Second row, second column. What is it? Second row, second column is 4y square plus y square. Second row, second column minus plus y square. What? Something is so. Second row, second column. Second row, second column is this. It's 2y and 2y is 4y square. A y and a y is plus y square. And a minus y and y is minus y square. I'm still getting a 4y square. What's the mistake I'm doing? Second row, second column. So which means have I done here also a mistake? Let me check the first row, first column. It will be x square plus x square. It seems like I'm getting a 4y square here. Correct? Let me check the third one. Sorry, I'm sorry to have guessed this answer. Third row, third column. What it will be? Third row, first column. Third row, first column is 0. Is zx plus zx, so 0. Third row second column is 2yz minus yz minus yz will again be 0. Third row third column z square plus z square plus z square. I'm getting 3z square. So this is different. This is what I'm getting. I hope my answer will be right. So I'm going to equate this with a 1 0 0 0 1 0 0 0 1, which means a 2x square is equal to 1. X is equal to x square is equal to 1 by 2. X is equal to plus or minus 1 by root 2. A 4y square is equal to 1. Let me check my answer because I don't want to have done any mistake. So this is sixth question, chapter 3. Chapter 3. Chapter 3. Miscellaneous. Sixth question. This is where it's wrong. This is where it's wrong. Which is 2 2. Second row, second column. A second row, second column. What is the mistake I've done? It's 4y square plus y square plus y square, 6y square. Sorry guys. Therefore 6y square is equal to 1, y square is equal to 1 by 6, y is equal to plus or minus 1 by root 6. Please make sure you're correcting this. Okay, so that's about it. So the next question. Next question is all matrices multiplication. You're equating them. You're multiplying the first with the second matrices, the second with the, and then that answer with the third, and equating with the 0 and finding the value of x. Okay, I'm sure 8th, 9th and all you can do. I'm doing the 10th question. Whatever is difficult only I want to do. So in this question, you see market 1, there's 10,000, 2,000, 18,000. Then the 6,000, 20,000, 8,000. You have the price vertically, you should write 2.50, 1.50 and 1 rupee. And this is the selling price in market 1 and market 2. Which, first row, first column. This is a 2 by 3 matrices. This is 3 by 1 matrices. You will get a 2 by 1 matrices. So first row, first column will come here. The second row, first column will come here. Thus you get the selling price total. You can add them to, you get the total selling price. Similarly, you take this matrices, write the cost price. Just write the cost price vertically. What is the cost price? It's 2, 1 rupee, 50 paisa, right? 0.50. Do the same thing. You get the cost price first row, first column, and second row, first column, one below the other. This is in market 1 and market 2, and you can add up, you can get the total cost price. And you can, the previous one answer and this answer, if you subtract, you get the profit. Profit is selling price minus cost price, which will come as matrices, which will be, there will be a 2 elements here, there will be 2 by 1 and a 2 by 1, so that you get the profit as 2, this is again a 2 by 1, and you add, you get the total profit. It's as simple as that. Okay, let's go to next question, which is the 11th question, which is an important sum, where there's an x, 1, 2, 3, 4, 5, 6 is equal to minus 7, minus 8, minus 9, 2, 4 and 6. This x is not a scalar for you to write it as 1x, 2x, 3x. It's a matrix x. This comes for board exam. I don't know, every exam this comes, the children think that's it's some constant x and they take it in. No. This is a 2 by 3 matrices. This is a 2 by 3 matrices. So it should have been a 2 by 2 matrices. Then only a 2 by 2 multiplied by a 2 by 3 will give you a 2 by 3, which is the n matrices. Therefore, you should know this is a 2 by 2. Therefore, you can assume this matrices to be A, B, C, D. And a 1, 2, 3, a 4, 5, 6. And write it as minus 7, minus 8, minus 9, a 2, 4, 6. Do first row, first column. Be A plus 4B. First row, second column, 2a plus 5b. First row, third column, 3a plus 6b. Second row, first column, c plus 4d. Second row, second column, 2c plus 5d. Second row, third column, 3c plus 6d. And you equate it to minus 7, minus 8, minus 9. You can solve this. You have to get the same value of ABCD, solve the linear equation and get it. You can open your Byju's site or Vedantu site and make sure you're getting the right answer. The 12th question in the textbook is omitted. Let's go to 13th sum. 13th sum is alpha, beta, gamma minus alpha. A square is I. It's been given A square is I, which means what? Alpha, beta, gamma minus alpha into alpha, beta, gamma minus alpha is equal to 1001. I is 1001. So therefore you write first row, first column multiplication. alpha square plus beta gamma. First row, second column, alpha beta minus alpha beta, which will be 0. Second row, first column, alpha gamma minus alpha gamma, which will be 0. Second row, second column, beta gamma plus alpha square is equal to 1001. So equating that elements, you know, alpha square plus beta gamma is equal to 1. Therefore alpha square plus beta gamma minus 1 is equal to 0, or 1 minus alpha square minus beta gamma is equal to 0. Choose the right answer. I think C is the right answer. Let's go to next question, which is the 14th question, where A is both symmetric and skew symmetric. How is it possible for a matrix to be symmetric and skew symmetric? That is, when you transpose, it is going to be the same. It can also be negatives unless it's a zero matrix, because zeros can be both positives and negatives. So the answer, option number B, is the right answer. Last sum, 15th question. The question is, if A square is equal to A, they're asking you to find what is I plus A the whole cube minus 7A. A plus B the whole cube is A cube plus 3A square B plus 3B square A plus B cube minus 7A. So look at this, I cube is just I. Identity matrices, how many times you multiply, it will be I. And I square is also I. I multiplied by matrices A will be just A. 3 and A square in the sum is given as A. So you can write A, I can be ignored because A multiplied by I is just A. And A cube can be written as A square into A, and A square itself is A. So it will become A square, and then it will be just A minus 7A. So then can you see a 7A here and a 7A here get cancelled? The answer is I. So this completes the gist of matrices. I made one mistake in one of the sums in multiplication. I'm sorry about that. I hope you all have noticed it. Please finish matrices and we'll start with determinants from next class.